I'm Katie Moussouris, Senior Security Strategist in the Security Development Lifecycle Team at Microsoft. I'm here at BlueHat talking to Chris Weber, a Managing Partner at Casaba Security. Chris, thanks for joining us at BlueHat, and you're going to be talking about
Unicode-related security vulnerabilities.
Very interesting. So tell us about that.
Well, I kind of split the talk up into two parts. The first part's on visual spoofing attacks, and the second part's on character and string transformations that lead to vulnerabilities.
So it seems like sort of two very different things here, but both related to Unicode. And
exactly.
I'm assuming the parsing and processing of Unicode and how that's handled differently.
It's a pretty complex standard. It's about 20 years old almost, and it's implemented everywhere in all operating systems, programming languages, and major frameworks. So the idea behind the visual spoofing is it's fairly well known, although it's kind of still been swept under the carpet in a lot of ways. The big famous attack was the PayPal spoof in 2005, and there have been several demonstrations since then. What I'm going to be talking about is kind of where we're at today with it and why it's becoming even more difficult to manage this problem, and presenting some solutions for how we can manage it.
So what are some of the solutions that you propose?
Well, actually, the Unicode Consortium has proposed some pretty good solutions, and by virtue of working on it so long, I've seen some other kind of angles to dealing with it. But there's this idea of actually detecting confusable characters or lookalike characters. So basically, you know, back in the day when we were starting in security, a lot of the focus was on network scanning. Now, for me and us, it's string scanning. We're literally looking at strings, taking them apart, and trying to figure out if different scripts might be confusable with other scripts inside the same string. So the other half of the talk is really about the classic sort of how to attack an application or a piece of software with malicious inputs. And I'll be going through different categories of attack vectors that you can use to exploit Unicode-enabled software, because Unicode has a lot of properties with characters. For example, simple character Latin letter A has these properties in Unicode so that software knows how to deal with it when you call an uppercase operation, a lowercase operation, when you normalize it, or when you try to transform it in some other way. So by sending in special characters into software, we can manipulate strings to do things such as expand by factors of 18 times. We can perform operations to send in a Turkish letter I that actually gets transformed to a Latin letter I for trying to bypass like a cross-site scripting filter. So there's lots of interesting sort of clever attacks and tricks you can do.
So it seems like they're using Unicode to bypass some of the security mitigations that are in place currently.
Yeah, we've seen these in the wild and through CERT advisories, mostly around WAFs, web application firewalls, for bypassing filters. The classic attack was Unicode string handling that leads to buffer overflows because people are counting characters instead of counting bytes, and that can be a big deal in Unicode.
Absolutely. So you've got multi-byte characters that you've got to deal with.
Yeah, especially when literally a single character can expand to become 18 characters under certain normalization and other transformations.
So in terms of that, what are some of the, I mean, is it just a cat and mouse game where, you know, the WAFs that you're talking about that are being targeted by some of these attacks, you know, that they just have to get smarter about what they're filtering or how they're filtering it? Or, I mean, what's the counter to this? How can people protect themselves?
I think right now it's really a developer, software engineer level awareness that's going to have to happen. The standards are pretty well aware of the problems, but the people implementing the standards might not be. So that's where we start to see these kind of errors. And because Unicode is literally baked into most frameworks, most people who are dealing with strings don't even think about it. So in that case, it's good to know sort of, I guess the action item for like Microsoft would be to try to secure their frameworks so that they default to safe behaviors, so they don't perform best fit mappings and they don't perform dangerous transformations by default. They've kind of noticed this along the way, but there's still cases where there's plenty of room for improvement in that area.
And then in terms of developers, where can developers, you know, go to really understand some of the security ramifications of using the frameworks as they stand?
Well, they can come to the presentation, you know.
Actually, Microsoft developers can come to the presentation.
That's right.
But yes, where can developers out in the world learn more about using Unicode securely?
Well, this has kind of been a flag we've been carrying as a company, so we've really been trying to build knowledge around this area, and we're actually in the process of building sort of a matrix of these frameworks and how they behave. So they can come to me, Kasaba Security.
Absolutely. Well, great. Thank you so much for joining us. I'm really looking forward to your talk.
Thanks for having me. I'm glad to be here.